In AS physics, it was nice and easy to split up the two separate units as they didn't really overlap. You had Unit 1, which was really mechanics and electricity, and Unit 2, which was looking at waves in space. It's not quite so simple in A2. In Unit 2 of A2, or Unit 5, we're going to be looking at fields, so that's gravitational fields, electric fields, magnetic fields. And when it comes to gravitational fields, which is one of the earlier topics we come to, we deal with things like orbiting planets. And that involves a knowledge of circular motion. So I'm going to be teaching you uniform circular motion, which is a topic from Unit 4, so it's 4.3. So it's a little bit out of sequence. And to start off with uniform circular motion, the first thing I want to focus on today is the circle. Now, there are plenty of things you should know about a circle, and in fact, most of what we do today you may already know, and that's absolutely fine. You know the area of a circle, which is pi r squared, but I'm not really interested in that in this case. The reason we're dealing with what a circle is that the unit that we're going to use in this topic is not the angle degrees. We have to use a different angle. And the angle we're going to use is the radian. So what is a radian? The definition of radian is based on the definition of the circumference of a circle. And you should already know that the circumference of a circle is equal to 2 pi times the radius of the circle, where a radius is the distance from the centre of the circle to its outside. We're going to deal with what is 1 radian as an angle. We have a circumference, which is essentially an arc of a circle that goes through a full turn of the circle. If we consider just a small section of that circle, where the length of the arc was equal to the radius, that angle is defined as 1 radian. So you're used to a degree, which is 1/360th of a complete turn. So what is a radian in degrees? Because the circumference of a circle is 2 pi times the radius, well, if we consider this arc of length equal to the radius, there must be 2 pi of those in one complete circumference. So if that's 1 radian has a length of r, well, 2 pi radians will have a length of 2 pi r. So in other words, one complete circle has 2 pi radians in it. So in other words, 2 pi radians is the equivalent of 360 degrees. If we divide that by 2, pi radian is 180 degrees. And pi over 2 radians is 90 degrees. Let's have a look at putting this into your notes. So on page 3 of your uniform circular motion notes, we cover this. We have the definition of 1 radian, and we can see how we can convert angles in degrees into radians. So 2 pi radians, 360 degrees, and so on around the circle. This diagram mentions in radians, an angle is defined as the ratio of the arc length to the radius of the circle. So I've called the arc length in this case S, the same way as we used S for displacement. And that'll make sense when we come to the rest of circular motion. So when the arc length S is equal to R, in other words, the arc length is equal to radius, the angle is 1 radian, R over R. If the arc length was 2R, so 2R over R, that will be 2 radians. And when the arc length is 2 pi R, in other words, one complete circle, we have 2 pi radians. So this angle theta is defined as S over R, where S is the arc length and R is the radius of the circle. Now, one thing that tends to cause an awful lot of errors at this part of the course is what mode your calculator is in. You have been used to using degrees, particularly in Unit 1 when you had to resolve vectors through different angles. You had your calculator set in degrees mode. It is very important that you have it set in radians mode for this. If you're not sure how to do it, let's have a look at how we can change the mode on this calculator. So up here, we can see it says D for degrees. We need to go into the setup. So in this case, it's Shift Setup. And the option should be 4 for radians. To check this, take the sine of the angle 30. Sine 30 equals, in this case, negative 0.988. You might be used to seeing that as coming as 0.5, but it's only 0.5 if we consider 30 in degrees. To get it back in degrees, shift, set up, 3 degrees. And here's sine 30 equals a half. So make sure that your calculator is in radians mode.